Hello everyone and welcome. This video showcases an implementation of the Map Block tool for generating volume mesh in ANSYS. If you're not familiar with the Map Block tool, watching the Getting Started video is recommended to go over a more detailed description of the basics. Mainly, the auto-split function will be used for decomposing the main volume, and with user intervention where necessary, it will lead to the creation of the subvolumes for solid meshing. We will also see the importance of split direction, the role of the caps, and useful advantages of Map Block. The model we will examine is consisting of a rectangle with two cylindrical blind holes and an area of level changes on the upper right part. As you see, the direction of the blind holes is different, and there are chamfers in the holes' heads. We will demonstrate the subdivision of the main volume into smaller blocks for the Map Block to identify closed volumes and create the mesh. The subdivision is done automatically up to a point, but the user also intervenes. We will demonstrate how to generate a structured mesh on the previous model using the Map Block function. In this model, the geometry is clean without overlaps or intersections. To check the prerequisites of the Map Block function, check the Getting Started video mentioned before. Press Ctrl-Shift to see the model in dynamic view mode. The part that we will try to mesh has two blind holes, one in Y and one in Z direction. Activate the Define Map Block function from the Volume Mesh ribbon tab in the Structured section. The Map Block tool, like other meshing functionalities, automatically uses the global parameters and quality criteria to generate the mesh. In the Parameters window, the target length is set to 10, as inherited from the predefined global parameters and quality criteria. Select the part in the drawing area using the left mouse button and confirm the selection with a middle click. A warning message will appear, indicating that the part's volume is non-mappable and requires further decomposition. Click OK to open the Decompose ribbon tab. To make the complex volume suitable for meshing, it must be divided into smaller, simpler subblocks. The auto-split function automatically detects where the volume needs to be divided. It creates splits by recognizing cones that, when extended in a specific direction, form closed volumes. In this model, extending the cones at the bottom of the holes can form closed cylinders across the entire width of the part. Similarly, extending the cones at the step area on the top right side creates closed blocks. The extension on the left cylinder is perpendicular to the XZ plane, in the Y direction. While for the right cylinder and the steps, it is perpendicular to the XY plane, in the Z direction. Activate the Auto-Split function. Auto-Split supports both planar and directional splits. In this case, due to the model's geometry, directional splits will be used. The extensions on the step and the middle hole should be made in the Z direction, perpendicular to the XY plane. To specify the split direction, set the vector in the Parameters window. Enter 1 in the third box under the Vector section and click Preview to see the proposed splits. The splits appear only in the cylinder because the vector 0, 0, 1 specifies the positive Z direction. Click Invert Vector Direction and then Preview again to see the splits in the negative Z direction. Now, the splits are created downwards using the cones of the step area. As demonstrated, Map Block can independently search along either the positive or negative semi-axis in a specified direction. The user can also set the search to occur in both semi-axes. Click on the right icon under Definition and select both sides. Click Preview. Now, the splits are made in both the negative and positive directions. Click OK to continue. Auto-split updates the model automatically. The newly created splits form mappable closed volumes that map block can mesh. These volumes are shown in green and labeled as ready to mesh. Next, we will create a split in the Y direction to close the volume in the other hole. Activate the auto split function, set the vector to 0, 1, 0, and click Preview. A new split is created as an extension of the bottom of the horizontal hole. Click OK to confirm. To view the boundaries of the closed volumes recognized by Map Block, check the caps on the Map Block legend, right-click, and select Show Only. The circular caps correspond to the cylindrical volumes created by the splits in the holes. These are mapped perpendicularly. Click All to bring the entire model back into view and uncheck caps. The interface between the main volume and the two smaller ones, which have circular caps with triangles pointing in different directions, complicates the orientation of the main volume. To resolve this, we will create a split in the main volume between the two holes. Activate the Plane Cut function from the Decompose tab. In the Parameters window, under More Actions, select Fill Planar Area to create a face in the section area. Select the midpoint of the edge and confirm with a middle click. The cut is made, and the face is created. Update the model and press Ctrl-Shift to view it in dynamic mode. The chamfer at the hole openings causes an inclined surface, which shifts the front face to the entrance level. This difference in levels makes difficult the structured mapping required by Map Block. To resolve this, we will decompose further by extruding the outer circle to create a tubular subvolume. Click on Not and select the three faces to hide them, revealing the wall of the hole. You can also see the face created by the plane cut. Activate Extrude from the Decompose tab and enable Loop under the Pick selection group. In the Extrude Parameters window, select Up to Target and set the direction to Normal to Target to extrude the circular perimeter perpendicular to the target face. Select the outer diameter of the hole as the source. Confirm with a middle click. Then, select the back face as the target to see a preview of the extrusion. Confirm with a middle click to create the tubular volume. Update the model. Click All to view the entire model. The volume is now mappable and labeled Ready to Mesh. On the legend, right-click Non-Mappable and select Show Only. Repeat the extrusion process for the second hole. Update the model. The entire model is now green and ready to mesh. Right-click Ready to Mesh on the legend and select Mesh. Deactivate the faces and use Not with Front only under Pick selection to see the generated volume elements. Click View All and reactivate the faces. Activate caps, right-click on them, and select Show Only to observe the volume subdivisions within the model. Map block updates the mesh with each update, according to the global mesh parameters. If the user wants to maintain a specific cap mesh shape during decomposition or map block updates, they must freeze it after making improvements. Otherwise, changes will be lost in future updates. Modifications made in one macro area will automatically propagate to the others. Click All to display the complete model. One advantage of Map Block is that it allows direct edit for fine-tuning the mesh, and the solid mesh updates automatically. Activate Edit Mesh under the Direct Edit section. Check the Quality Monitor drop-down menu to see how the number of pentas and hexas changes with each action. Join two triangles by dragging one onto the other to create a quad. Then, split the quad and join the resulting triangles. Deactivate the faces to observe the automatic updates in volume elements. You can also remesh the model at any time using different parameters. To do this, delete the volumes from the list. Go to the Volumes list, select all subvolumes with Ctrl-A. Press Delete. And confirm by pressing Enter. Close the Volumes list window. Activate Map Block from the Volume Mesh Ribbon tab and change the target length to 12. Select the part and confirm with a middle click. The part is now remeshed with the new parameters. Close the function window, right-click Ready to Mesh, and select Mesh. Deactivate the faces to view the newly generated volume mesh. Remeshing is complete. Thank you for watching.